From the previous video, you probably got the idea that heteroscedasticity is quite dangerous and we need to deal with this. And you're right. And now I will tell you how to detect heteroscedasticity. There are two types of methods, informal and formal. Informal methods include understanding, exploring the nature of the problem, and graphical method. And the formal methods include a number of tests that I will discuss in a second. But let's start with informal methods. Very often, the nature of the problem under consideration suggests whether heteroscedasticity is likely to be encountered. So, when you come up with the problem with the problem for your analysis, just think logically whether heteroscedasticity might be present in your data set. For example, if you're dealing with cross-sectional data involving very heterogeneous units like human beings, then heteroscedasticity might be the rule in your case rather than the exception. For example, if you analyze such series as investment expenditure in relation to salary rate of interest, family budget, wages in relation to years of school, and be aware that heteroscedasticity might be present there. So I think from this example you should get 2 points: that heteroscedasticity is very much present in cross-sectional data, and it is also present when you deal with very diverse units like human beings, when you compare, for example, their wages to the years of schooling, or when you compare their income to their consumption. So those are the 2 cases when the nature of the problem already tells us that there might be the problem of heteroscedasticity in your data set. After you've done this analysis, you can move to another informal method, which is called graphical method. To apply the graphical method, what you need to do is the following. So you need to plot estimated residuals against estimated values of the dependent variable or one of the explanatory variable. And if there is a systematic pattern between the 2 variables, heteroscedasticity might be present. So once again, we take the estimated residuals from our main regression model and we plot it either against the dependent variable or the estimated values of the dependent variable or one of the explanatory variables. And if you see that that there is some systematic patterns, that the behavior of the residuals is a bit suspicious, then heteroscedasticity might be present. And let's have a look at this figure. So those are the hypothetical patterns of estimated squared residuals. So for example, if you look at graph A, this is a normal case. So here there is no systematic pattern because we see that the residuals are quite random. However, if you look at graph B, you will see that there is a systematic pattern, and the residuals get more spread out with the increase in the values of y. If you look at point C again, we can see that there is a systematic pattern. Actually, there is a linear relationship between your residuals and the estimated values of y. So this is another example of heteroscedasticity. Point D, I think it's not even necessary to comment anything here because the pattern is quite obvious. All right, so at first the residuals increase with the increase in values of y, and at some point they start decreasing with the increase in the value of y. And E, this is also the case of heteroscedasticity. All right, again, there is some special relationship between estimated residuals and the estimated values of y. So from this graph, we get that only A is the example of homoscedasticity, whereas all the other 4 graphs, those are the examples of heteroscedastic error terms.